Yes. Better, do anyone remember what we discussed in the last session? No? ECS? Yes. But only one student? Okay. So, but today we'll be starting with our another topic, and the topic is AWS integration and messaging. Okay. So if you want to integrate multiple applications, and suppose if you want to send a messages or a notification, and it can be within the application, suppose S3 bucket wants to send a message to EC2 instance, or any RDS wants to send a message to the Lambda function. So it can be within the application, or it can be to the users. Suppose you have the e-commerce website and you want to have an email messages that the order is placed, or someone cancels the order, or if it is a delivered. So messaging and integration is going to be the another very important point for our discussion. Okay, so we'll be starting with AWS integration messaging. So let me just share the screen. Give me a second. But please tell me, is my screen visible? Okay. So we'll start with the AWS integration and the messaging. So there are a few things that we need to discuss. One is SQS, then we have a SNS, then we have a Kenyans. So these are the three services that we'll be discussing under the AWS integration and the messaging. So the very first part we need to discuss is in under this is there can be multiple things, like there are two types of messages that can be shared. One is synchronous communications, and the second one is asynchronous communication. So what is the difference between them? Let's try to understand. So when we start deploying a multiple applications, they will be inevitably need to communicate with each other. So there is no two applications that can ever function without having a communication with each other. Okay. So no matter if it is a multiple modules are there that need to communicate within the same application, or if it is the multiple applications that need to be communicate with each other. So this is very much common that your application needs to have a communication with each other. Okay, so there are two type of patterns of the application communication that we have discussed: synchronous and the asynchronous. Now, but in synchronous communications, it directly happens from one application to the another application. Okay, so there is no intermediate body between this synchronous application. Suppose buying service, someone is going to buying something, and then the same details are going to be sent to the shipping service. So someone has bought something, suppose a mobile phone. Now mobile phone needs to be delivered, so the details has been shared with the shipping service. So the two applications or the two bodies that are involved, which are going to have a synchronous communication, means the messages are shared that directly between the two applications. So this is one type of the communication that can happen. Or the second one is the most common is the asynchronous or the event based communications. Okay, so suppose there's a buying service and there's a shipping service, and we are going to have a queue between them. Now whatever the messages that are originating from this buying services, they are going to be present within the queue, and the queue is going to forward these messages to the shipping service. Now someone can ask, sir, why do we need to have a queue between them? So if they can communicate directly, because there are a lot of reasons that we need to have. Because the one and the very common reason is, let's take an example. Suppose this is a, let's take a video streaming application. So that needs to stream 100 on one day. It usually stream 100 videos. Okay, so and they need to send a data, and they need to store it in S3 buckets. Now let's suppose one day, instead of 100 videos altogether, they need to stream 1000 videos, 10 times their capacity. So if the capacity, if they are going to process more than its required capacity, if there is no intermediate queue, but this shipping service might crash. They might not be able to take so much of data. So we need to have a some intermediate body that can take a message from one service and it can maintain a queue, and one by one it will send a message to the shipping service. So that's the another type which we call as the asynchronous, because messages are not directly sent from the source to destination. So there's a queue in between. So first of all, the message will land in the queue, and from the queue they are going to send further. Coming on to the next one is the synchronous between the applications can be a problematic. So this is what we have been discussing. Synchronous the communication between the application can be a problematic if there are sudden spikes in the traffic. Okay, so मैंने आपको बोला बेटा, instead of 100 video streaming, suppose you stream 1000 videos. Okay, so उस case में sudden spike आएगा traffic में, then it will be a problematic. So what if you need to sudden encode 1000 videos but usually you do 10? तो ये example given है, generally you encode 100 videos, 10 videos, but now you want to encode the 1000 videos. So that means all of a sudden there is a spike in the traffic. Okay, so in that case this synchronous communication might not function well. So there will be a lag, or there will be a delay, or the receiving server might crash. Okay, so in that case we need to have a asynchronous communication so that things can work smoothly. So in that case it's better to decouple your application. That means decouple means instead of one complete full-fledged package, we can decouple it so that they can communicate within the multiple modules and in the better way using the third party or like a queue. Okay, so there are multiple ways using SQS queue model. Then we can use the SNS pub sub model. And what is this pub sub? But a pub stands for the publication, sub stands for the subscribe. Okay, pub sub model. Then we can use the Kenyans in the real-time streaming model. So we'll discuss all three one by one. So these services can scale independently from one application. So that means they can scale. They are not dependent upon other applications. So SQS can scale independently, SNS can scale independently, and Kenyans can also scale independently. So these are the few services. So let's discuss the first one. Let's discuss what is Amazon SQS. What is the first one? What is Amazon SQS? क्या है बेटा, इसका क्या model है? How this is going to work? So let's try to discuss first one. So Amazon SQS, beta, there is first thing that you need to understand. There is a queue. In the center, you will find there is a queue. Now, whenever there is a queue के अंदर बेटा क्या store होगा? What is going to be stored inside this queue? Of course, we are going to have a messages that are going to be sent within the queue. But who is going to send the message? A producer. There can be a producer who is going to produce the message and who is going to send the message. Now, parallelly, there can be multiple producers that can be connected to the same queue. Okay, so there can be 5, 10, 20 producers that can be parallelly at the same time can be connected to the single queue, and they can send the message to that queue. Now, this SQS queue is going to receive the message from the producers and it is going to store it. Okay, so this queue is going to have the message received from the producers, and then consumer is going to pull the message. So, but it is not like automatically these messages will be sent. Consumer can request the SQS queue that do you have any message for me? Then queue will say that let me check. So it will check, and if there's a message for any particular consumer, it is going to forward. So this is how the SQS queue is going to work. So there's a send message from producer side, and there's a message going to be delivered at the consumer side. So this is a simple funda how the queue is going to work. Now, standard queue, beta SQS is the standard queue. Why is it the standard queue? This is the oldest offering of the AWS, which is over 10 years old. तो ये बहुत पुराना AWS का offering है, that is more than 10 years old. SQS queue, which is the standard form, it is offered from a very long time in AWS. Now, the second point is it is fully managed service used to decouple the applications. Of course, this is asynchronous. So using the queue, you can decouple the applications. Now, there are few attributes of this SQS. And what are those attributes? So you're going to have this unlimited throughput. So that's a very good thing. Unlimited throughput, unlimited number of messages in the queue can be there. So these are the few attributes. Default retention of message 4 days. So if a producer is going to send a message, but by default, it will stay in the queue from 4 days to maximum 14 days. यानी कि कम से कम वो मैसेज 4 days के लिए प्रेजेंट होगा, एंड मैक्सिमम टू मैक्सिमम दैट मैसेज कैन बी प्रेजेंट अप टू 14 days. The third option is low latency. Low latency means less than the 10 milliseconds to publish and receive. So suppose a producer is going to send a message to the queue, and the receiver is going to get it. So it will everything will happen in less than the 10 milliseconds of a time. So latency is going to be, or the delay is very less. So limitation of a message is you can send a message up to 256 kilobyte per message. Okay, that's the maximum limit of message that you can send. Okay. The third point is can have a duplicate message. Suppose if one message can be sent multiple times, so at least once a delivery occasionally. So you'll not have a message loss. So data loss nahi hoga beta. So at least once delivery means that message can be sent multiple times as well. So but at least kam se kam ek बार तो वो जरूर deliver होगा. And it can have out of the order message best offered ordering, that we'll see when we'll discuss the practical. Coming on to the next one, SQS producing message. How the message is going to be sent. This is a producer side. Okay, this is a producer side message up to 256 KB, which is going to be sent to SQS queue. So this is going to be queue that is being made. So producer to SQS queue using the SDK. So software development kit, and it is going to send the message using the APIs. The message is persisted in the SQS queue until the consumer deletes it. Okay, so this is the second point, is a very important point. While we'll be discussing now practical, we'll be looking on to it. The message persisted, that message will be present in the queue until consumer deleted. The moment consumer deleted, beta it is going to be deleted from the queue as well. Okay, so jab tak consumer delete nahi karta, it will be present in the queue. And by default, the retention rate is going to be from 4 days to up to 14 days. The message can be there. For example, send an order to be processed. Suppose there is an order that I want to process. So it is going to have few items into it. It will have the order ID, it will have the customer ID, it will have the multiple other attributes. So everything will be written inside this message and it will be sent to the queue. Now suppose this queue has got the message. Now I want to send this to the, let's suppose, shipping team, or I want to send it to the query team, or I want to send it to the refund team, or I want to send it to the email notification to the client. So there can be multiple messages that can be required to be sent. So this SQS standard is the unlimited throughput. So you can have the throughput can be very good and it is unlimited in nature. So consuming message. So the previous slide we have seen how the message is going to be sent to up to queue. Now we'll see how the consumer is going to consume the message. Okay. Now let's see consumer running on EC2 instance server or AWS Lambda. Consumer can be anything. So this is a consumer. It can have any instance running. It can have any application running. It can have any of the businesses that is there. Now poll SQS for message. Poll SQS means it is going to request the queue for the messages. So this consumer is going to request the queue for the message, and it will, when it will send a poll, then the queue is going to send a message to the consumer. Okay, the first signal is poll SQS for the message and receive up to 10 messages at a time. So single time you can parallelly receive at least 10 messages. Once the poll request reaches to the queue is going to respond with the processing of the message. Example, insert a message into the RDS database. Suppose message के अंदर क्या लिखा था कि insert the data into the RDS database. So जैसे ही message बेटा consumer के पास पहुंचा, so it is going to insert a data into the RDS database or S3 bucket or anything. Okay, once the consumer has processed the message. Okay, so once the consumer has processed the message, it can obviously delete the message. Now once the message is deleted, better it will be deleted from the queue as well. Okay, so once the consumer is going to delete the message from its end, it is going to be deleted from the SQS queue as well. Coming on to the next one, SQS multiple EC2 instances consumers. Now let's suppose that it's not like that this is the queue and it can send a message to the single consumer, because if you'll see here in the previous slide I have told you the queue, multiple producers can send a message at same time to the single queue, and this queue can also send a message to multiple consumers at the same time. So this is what we are going to look at now. So it is written SQS multiple EC2 instances consumer. So this is the queue, and these are message 1, 2, 3 messages are sent to EC2 instance, and this is the same message. Let's suppose the same message needs to be sent to the multiple queue, so same thing can be done. So consumer receive a process message in parallel, at least once delivery is there. So even if one of the messages is going to fail, still at least one delivery needs to be successful. So this is the best effort message ordering. Consumer delete the message after processing them. We can scale consumers horizontally to improve throughput of processing. So we can scale the consumer. So very easy. We have discussed this parallel it can observe. Now, once let's suppose multiple messages are there, better there is going to be a saturation point after which suppose the instances are not able to take the message. So उस केस में क्या है बेटा, हम we can wind up everything inside the auto scaling group and we can have a alarm triggered. So CloudWatch can be there. There can be auto scaling group. So as the messages are going to increase, if these instances are not going to process them, so when the alarm is going to trigger, automatically new instances should be launched. So something like this is given in the next slide. So let's try to look onto this. So SQS with the auto scaling group. Okay, so this is the queue. This polls a message, and there are 3 instances running on EC2, which is of course attached to the auto scaling group. Okay. Now let's suppose these instances are not capable of processing all the messages. Let's suppose thousands of messages are there, and these instances are not capable of processing all of them. So there is going to be a CloudWatch metric which is going to be linked with the queue length. Now this is the one of the attribute which is linked to queue length. So agar queue ka length, but let's suppose I set the parameter कि queue ka length if it is greater than 100 or if it is greater than 500. So in that case, alarm CloudWatch alarm is going to be triggered. Once the alarm is triggered, I'll give the signal to the auto scaling group that scale the instances so that all of the instances can be processed. Okay, so this is a similar kind of familiar structure that we might have already seen multiple times during this course. So the purpose is the messages can be attached to the CloudWatch metric, which can trigger the alarm, and once the alarm is triggered, auto scaling group can automatically increase the instances so that the SQS queue can send a message to the EC2 instances and they can be processed. So this is the another form. Coming on to the next is SQS2 decouple between application tiers. Okay, so there are multiple applications. Now let's take a simple application. But there is a producer that requests a service. Let's suppose you know, to have the video editing. Okay, let's take an example of the video editing. But agar aapko video editing karni, let's suppose there are 100 videos that you want to edit, and if you're going to edit it onto the front end, let's suppose this is the front end and you're going to edit in the front end and you want to send it message to SQS queue. But it become really very difficult to process 100 of the video editing at the front end, and this makes the processing little slower. Okay, so it will slower, website will become slow, the response time will increase, latency will increase, throughput will decrease. So because of all this, the send message to SQ queue will be late. Or what you can do is, you can, instead of in processing the request at the front end, like example is the video editing, you can send a message to the queue, and this queue can have all the list of the tasks that it needs to be done. You can have the backend to which this queue is going to be connected. So this backend is going to process one by one all the applications, and it is going to insert into RDBMS after the processing. Okay, so this is another way of using the SQS service. That means instead of doing everything at the front end, you can use the queue and reassign the tasks to the backend so that they can process it. Okay, this is another way of using the SQS queue. Now, then is the Amazon SQS security. Do I try to read it once? Read it once, Amazon SQS security. Read this, then we'll have the practical. SQS security, but there is an encryption that can be employed onto the SQS. The first is in-flight encryption. That means when the data is moving from one application to another using the HTTP is secure API, or data at rest can be encrypted using the KMS keys. This is by default provided by AWS. Default provided by this is using, it can use the KMS keys default provided by AWS, or client side encryption if the client wants to perform encryption decryption itself. So suppose if I want to no, I don't want to use the KMS encryption provided by this what we call AWS, then I can use my own encryption decryption mechanism. The second point is the access control. Okay, so we can use the IAM policies that allows to access to the SQS API. So we can set the policies. That's the second security mechanism. The third one is access policies like the bucket policies. We can write the JSON document similar to the S3 bucket policies. We can write the SQS access policies, and it will be useful for the cross account access. Cross account means from one of the account you want to access it to the another account. In that case, you can assign this. We can define this bucket policies, and it is useful for allowing the other services like SNS, the second services that we'll be discussing now, or S3 service which can write to the SKS queue. So SKS queue beta can interact with the S3 bucket also. SKS queue can interact with the SNS, but these are the different application which we call as the cross account access. Okay, so that can also be performed by using the security mechanisms. Okay, so let's move and first of all see what is SQS. Okay, then we'll move on to SNS. Let me move to the management console. Okay. Okay, so we'll write simply SQS. The moment I will write SQS, we'll get a simple queue service. Okay, so we are going to click on the create queue. The moment you click on the create queue, beta, you'll be prompted with this screen. So it is written you can't change the queue type after you create a queue, which is okay. And there are two types of queue. One is the standard queue. At least once delivery, message ordering isn't preserved. At least once delivery, best effort ordering, or we can have the FIFO. FIFO means the ordering is going to preserve. So first message beta, you are going to put it into the queue. That will be the first message that is going to be delivered. So first in first out, either you can save the ordering, or if you're going to use the standard one, so the message ordering isn't going to be preserved. So there are two options. I can use the standard, or you can use the FIFO. So as of now, I'm going to use the standard one. So let's try to write the name. So I'm going to write demo queue. So then we'll have the configuration. So in configuration beta, you will see the visibility timeout is 30 seconds, and then we'll have the delivery delay, and it is going to be 0 seconds. How much delay you want to have in the delivery, message retention period, and before this we'll have the receive message wait time at 0 seconds, then the message retention period. But here you will see it is written should be minimum 1 minute to the 14 days. Okay, so retention period, so from 4 to up to maximum of 14 days you can have it. So when you click on here, so you can have maximum time that is allowed is 4 to 14 days from seconds, milliseconds. Okay, then we have the message. Give me a second. Then we'll have the maximum message size. So the maximum size is going to be up to from 1 KB to 256 kilobyte. It needs to be there. Okay, So these are the settings that are default, and I'll keep it as it is. So let's move to the next one, and this is very important section, that is the assess policy. Okay, so in the assess policy, you will see who can define who can assess your queue. Okay, so who can assess your queue? So it's a basic and the advanced one. So if you look the basic one, you will find that that only the queue owner should assess it. Okay, or it can be the specified AWS account, IAM users, and the role. So multiple options are there, and you will see the corresponding to the assess policy. There is a JSON document which has written that who can assess the message. So ID, default policy type, statement ID, owner statement, effect is allow, principle is this one, action is SQS, simple queue service, and star means every of the message needs to be allowed. Resource is, this is the resource that is being given. So that's a very simple policy. And define who can receive the message, only the queue owner. That's the option that is given. Okay, the next one you can choose is only the specify AWS account. You can click on this, and you need to write which of the user needs to be assessed this particular message. You can click on this, and you can write any of the user in this, and corresponding you need to make a change into this JSON document. Okay, that's the one point, and we'll keep it as the only user. And then you can click on the advanced one. So if you'll click on the advanced, you will see use a JSON object to define an advanced assess policy. So you can click on the policy generator as per your own businesses. If you want to have the advanced level policy, you can click on it and you can generate. Okay, so that's the one basic. So we'll jump to the basic one. Everything looks fine. And the purpose of basic and advanced is going to be same. So as per your business requirement, you can do this. Now coming on to the next one, we have the encryption mechanism, read drive allow policy, optional. These are, everything is optional. So it is written Amazon SQS provide in transit encryption by default. So HTTPS API. So by default encryption is going to be provided. To add the REST encryption, you need to you need to enable this. But when the data is moving, so simple queue service SQS by default this provides the encryption. This is done. So you can enable this if you want to enable this. So then you need to choose the encryption type, or KMS is the default one, or ESSQ. So you need to choose which one. Okay, so when you click on this one, you have the customer master key, that is going to be the default. Okay, then you'll have all the details. Account number is also mentioned here, and the data use key reuse period is 5 minutes. After 5 minutes the same key can be reused. Okay, so let's create a queue. So now we can go ahead and we can send and receive the message from it. Okay, so we get a lot of different panels in this UI. Now we'll see, but when we want to go through the top and right side corner, we'll see the option send and the receive message, and click on send and receive message, and click the facility for us to send a message. Okay, send and receive message, you can write it, and you will have the two options. One is the send message, this is from the sender side, and then you'll have the receive message, this is from the receiver side. Okay, so you can write it. So here is a facility for us to send a message. Okay, and then the bottom to receive the message. So as we can see, we have the 0 message available right now, but if I enter hello world in the message body here, I'll enter hello world, and then send the message. As you can see, the message is sent. Now it is ready to receive. Now we have two messages available, one. So receive message, message available is 1. As soon as it is here, as soon as I click on poll for the message, you will see here the message will appear here. I click on the poll for the message and the message is going to appear here. Okay. As we see, we have a message ID. And if you want to look on the contents of the message, click on this and you will find I can have some information here. So a lot of metadata around this message. For example, hash of the message is there, who sent the message, and just time right now. Okay. When is the first time, when the first time we are going to have this message, ID, size, who received the message. Okay. Message body, sender ID, message count. Okay. Attributes can be there. So a lot of details are available. Size is given, 11 bytes data is given. Okay. And what exactly body means, what message you have got, and this is how we can see the message, who, what message has been sent. Okay. And if we have created some of the attributes for the message, and we can see it here. So let's click on the done. So when you send the message and then read it, you get the same exact message. But we have to decouple it because the user has sent some information. So the consumer has received that information. So there is there. Now we can send the message that has received twice. We can send the again message. So message available is 2. Okay. So the received count is there. So maximum message count is 10. Polling duration is after 30 minutes. It can poll. The message went back to the queue after this. So automatically the message is going to be there. It is again polling. So start for receive 2 message. It is going to be 3. So automatically it is going to send the message. So it has been read yet again another time. So again and again the messages are going to be there. Now once I click on, now since it is going to be sent again, so I'll need to click on process this hello world message. So we need to click on this and I'm going to delete this. Okay, I'm going to delete this. Let's click on delete. By deleting the message, now you have signal the SQS that the message has successfully been processed. Okay, and therefore when you will see here the message available, this is going to be there. Well, okay, so let's go ahead and send, just play around and we'll send some message attributes. Okay, by the way, this is an optional, you can set the as message attributes. Now when you'll have this, again send, send multiple times. So you'll see the message available is 4. We have sent multiple times, and you can just play around and you will see there are multiple. Let me poll for the message. You'll see multiple times I have sent. These are message I have been getting. So you can click on delete. Okay, so messages have been deleted. And when you click on stop polling, so now the automatic message that we have been getting. So fairly easy. So this is the concept of the producers and the consumers. So stop pulling. Now we'll not be having any of the messages. Okay, we have clicked on the stop pulling. So let's move back to our demo queue. And there are a few options as well, as you can see out. So edit, delete, purge, send and receive. So when you click on the edit, so you'll have the configuration and the access policy that we have seen before. So cancel. Let's move back to the purge. Purge means this is going to delete the messages which are present in the queue. Okay, so you can whatever messages are present in the queue, if you want to delete that, so simply purge it and you will be able to delete it. So messages present in the queue are also deleted now. And this is going to be very helpful when you do the developments, that if any of the wrong messages are being present here, if you want to delete it. But I don't think you should do this in the productions, but in the development this is very important. Then we'll have the some information around the monitoring. You'll have the lambda triggers monitoring. Let's click on this. Around how many messages are present in the queue. So number of messages are present in the queue, which is the oldest message, and approximated age. Another way to scale, and if you have auto scaling group rating from it, okay, approximated age, number of message sent, message size, message received. Okay, so all this are present. Then we have the access policy. Okay, and these are which can who can access this queue and how, who can access this, that is being present here. And finally you can see the encryption. So it is CMK, and the data key reuse period is 5 minutes. So after 5 minutes the same key can be used. Okay, so this encrypts the message which is at rest. So by the way, the message which is in the transit, these are the encrypted by default, as we have seen at the time of creation of queue. But the message when it is at a rest, if you want to encrypt it, we are going to encrypt using this CMK encryption. Okay, so that's what the overview for the SQS section is. Now we'll have a look at the few more options and how this is going to work. But are you able to see this, how we can create a queue?
Yes, sir.
Okay, so give me a second, beta. Next is okay. So this is going to be the next slide. Okay, so next we are going to see with the Amazon SNS. Okay, so SQS simple queue we have seen, and now we are going to start with the next one, Amazon SNS. So beta, what if you want to send a message to the many receivers? Suppose there's one of the service that want to send it to email notification, you want to send it to the fraud service, you want to send it to the shipping service, and you want it to the SQS queue as well. Okay, so one message, when you want to send it to multiple, you will have the one possible solution. You can have the direct integration of the one service with the another lot of service. As you can see, this might look simpler because this is the very simple we are trying to understand, but in real time integration of all this multiple things services with the single service is going to be very complex thing. So this is one of the solution, direct integration, or otherwise we try to use the pub sub integration. Pub sub I have already told you. Please tell me, let's see how attentive you are. What is pub and sub? But I've told you. What is pub sub? No, no public. But a pub sub mean S for subscribe and P for publish. P stands for publish and S stands for subscribe. Okay. So instead of having a direct integration of lot of services, we try to use the pub sub model. Pub sub model में क्या है? There is going to be one service, but whatever messages they want to send it, they are going to publish it onto the SNS topic. So there is going to be another body, central body, which we call as the SNS topic. So whatever messages are there, it is going to publish it into here. The message will stay here, and these notification, fraud service, shipping, SQS, they can subscribe. Better, they can subscribe to SNS topic. Now, lot of subscriptions can be there that can subscribe to the SNS topic. So with this SNS topic can send a message to the multiple services. But at the end, if you'll see that buying server needs to send only a single message to the SNS topic. Now this SNS can further transfer this message to the lot of services, but this makes the structure little bit simpler. Okay, so you can have a lot of subscribers, or the subscriptions can be there that are going to subscribe to the SNS topic, but they are not directly relating to the buying service. So the buying service need not to send a multiple messages. They just need to send a single message to the SNS topic. Now SNS topic is responsible for forwarding this message to the multiple this services. Okay, let's try to see this. Try to read this slide बेटा, एक बार read करो इसको. So very easy. Okay, the event producer. Who is the event producer in this case? Event producer can be one of the application or the service on this side. Okay, so they can only send a message to the one SNS topic. So only one message is required to be sent. So likewise, this is the one service, they need to send only one message to the SNS topic. Once SNS topic has got messages, they can publish. Better, now they can publish messages to lot of services like SQS queue, Lambda function, Kinesis data warehouse, emails they can send it, they can send the SMS and the mobile notifications, they can send it to the endpoints of HTTPS servers. So they can, this SNS topic, this can be connected, or this can be subscribed by lot of other services that can access the message from the SNS service. Okay, so that's the beauty of it. So as many event receivers or the subscriptions as we want to listen to the SNS topic notification. So jitne bhi beta subscription wants to listen to the notification, they can subscribe to the SNS topic. Each subscriber to topic will get a message note, few new feature to filter the message. Okay, so this we'll see in a while. Yeah, aapko main abhi beta I'll show you how you can filter out the message. But abhi ke liye try to understand that each subscriber to the topic will get a message. So if there's a one message and it wants to send, each of the subscriber can get the same message. Maybe we'll not be using last 2 points, but it is important for the general knowledge that up to 12 millions, more than 12 million subscribers can be there per topic that can subscribe to this SNS topic, and more than 100,000 topics can be there that can be listed down within this SNS. Okay, so that's a few data that you need to know. Then we'll have the SNS integrates with a lot of AWS services. Now, this SNS services, as we have seen in the previous slide as well, they can integrate with SQS queue, they can integrate with Lambda function, Kinesis data warehouse, and moreover, they can integrate with lot of services like CloudWatch Alarm, Scaling Group, Cloud Formations, DBMS, and buckets, budgets, Lambda functions, DynamoDB, RDS events, and lot more services are there that can be directly linked to the this SNS topic. And then moreover, beta, you just simply, the funda is you need to understand जहां जहां पे भी आपको मैसेज की जरूरत पड़ेगी internally within the AWS, every service is going to be attached with the SNS. Okay, so this is a simple way to understand. Many AWS services can send that data directly to the SNS for the notification, so they can send it directly. Now coming on to Amazon SNS, how to publish. Beta publish hota kaise? And by the way, this SNS publishes same as the Kenyans publish. So next topic that we'll be doing, उसमें भी publish का steps जो है वो same है. So this is the same steps. So Amazon SNS, how to publish it? So topic publish using the SDK software development, create a topic, create a subscription for many, publish the topic. Very simple. Direct publish कैसे होता है? For mobile app SDK, create a platform application, create a endpoint, publish to the platform endpoint, work with the Google GCM, Apple APMS, Amazon ADMs. So this is the point where you can publish, and we'll see it in the practical how we can publish the SNS. The next one is going to be the Amazon SNS security. Read it, then we'll move on to the practical. And if you'll see better, this is same as that of the SQS queue. SNS topic के बेटा जो security है, all three steps: encryption, access control using IAM, SNS access points. This slide is exactly same as that of SQS queue. Read it once, then we'll move on to the queue. Then we'll move on to the management console and we'll try to execute this. But this will be the last week for our training, and Friday our training is going to end. Before that, I have already allocated the assignment number 2. I hope everyone has seen it. Try to complete it within time. Okay, no extension will be provided. And towards the end of the training, I'll also show you how you can close any of the services that you have started, how you can view the pricing and the billing dashboard. हम बिलिंग कैसे चेक करते हैं कि कितना बिल है कितना नहीं है. So we'll do discuss that points as well towards the end of the training. So I hope everyone has read this slide, so nothing difficult in this. So let's move on to our management console and execute. Okay, एक दो बेटा स्लाइड्स और हैं वो भी कर लेते हैं. Fan out, yes, this is important. Okay, fan out is also important. Now, but in this case, SNS plus SQS fan out. So these services can work in collaboration. And what we mean by the fan out and how the filtering is going to happen? बेटा filtering मैंने आपको last में बताया था. There is going to be filtering process. So this is how the filtering is going to happen. So let's discuss this once. तो एक ही बार हम लोग इसको execute करते हैं. So let's suppose you push in one of the message onto the SNS topic. Okay, to receive all in the SNS queue that all the subscribers fully decoupled, no data loss. Okay, now you will observe but this buying service sends only a single message to the SNS topic. Now this is going to have all the topics listed here, and SNS can have the subscribers. Okay, now within that subscriber, if you have seen बेटा एक उनमें से subscriber आपका SNS भी हो सकते हैं. So you will see here in the previous one. So this is the SNS और इसका एक subscriber क्या है? SQS service. Okay, so SQS service can be a subscriber for the SNS. So same thing is displayed here, that this is the SNS queue, and you can have the SQS subscriber 1, SQS subscriber 2, and this queue is further attached to lot of other services. Okay, so what is the benefit of having the queue along with the SNS? So once you push a message on SNS, it is going to be received by all the queues that are attached to it, because SNS will send a message to all the subscribers. So these queues will get the message that are the subscribers. This is fully decoupled because there's inside we are going to have a queue, so there is no chance of having a data loss, because queue का property ही ये है कि at least once delivery is there. So that's the property of the queue. Now, further, this SQS is going to allow for the data persistence, delayed processing, and retire of the work. So, few of the features that are the unique features that are being provided with the SQS that can also be used. So, an ability to add more SQS subscribers over the time. Make sure your SQS queue access policy allow the SNS to write. So, these two needs to have the policy so that SNS is allowed to send a message to the queue. So, there needs to be a policy. Coming on to the application S3, events to the multiple queues. Okay. So in this, you will have, suppose S3 object is created. One of the event is going to push the object or the any of the image on S3, and there is going to be a message that is going to be sent to the SNS queue, and that needs to be sent subscribed out to the lot of queues. Now, let's suppose you want to send that message only to one of the queue and the lambda function, but you don't want to send it to the one of the queue. So you can fan out few of the queues. Fan out means to uh, fan out means simply that you don't want to send the message and you're going to leave that particular subscriber, and apart from that subscriber you want to send it to the lot of other subscribers. So you can temporarily ignore one of few of the subscribers to which you don't want to send the message. So that's what a fan out is. For the same combination of events type, object is created and the prefix images are there, you can only have the only S3 event rule. So only one of the event can be able to send this message here. So if you want to send the same S3 event to many SQL services, you need to use the fan out. Coming on to this one, leave this. Then we have the SNS service. How this SNS is different from SQS? You use the FIFO topic, and this is very easy. As you can see, the producer is going to send a message to the SNS. Message is going to send to 1, 2, 3, 4. That means first message will be sent 1, then the second is sent, then the third is sent, then the fourth is sent. Same sequence needs to be followed for the subscriber. The first message will be received, then the second, then the third, then the fourth. Same sequence is going to follow. Similar feature as of SQS FIFO. So ordering is going to be done by the message group ID. So there is going to be a unique attribute along with which you're going to order it. So decoupling using the decouplation iCard and the content based decoupling is there. Can only use the SQS FIFO queues as subscriber. Limited throughput is there. So these are a few of the features. Let's move it. Okay. And out. Next one is the filtering. Okay. So filter out process, you can use the filter out JSON policy used to filter message sent to the SNS topic subscriber. If a subscription doesn't have a filter policy, it receives every message. So otherwise, if no filter policy is there, so everyone is going to receive the message. Otherwise, let's suppose there is a service and it has sent a message to the SNS topic, और उस message में क्या लिखा था? Order number, product का details, quantity, state from where it is placed. But let's suppose you're having queue in which only placed order information needs to be stored. Okay, so there's another queue where only cancelled order information needs to be stored. So there is an queue where only cancelled email subscription needs to be stored. So declined order needs to be stored. Okay, so there are few specific queues where you don't want to send order, product, quantity. All these information need not to be sent to all the queues. So order number needs to be sent only to first one, and the cancel order needs to be sent to the second one. So you can filter out that what particular information out of SNS queue needs to be sent directly to this queues. So that's the filtering policy. Okay. So, okay, let's move. So this is a few differences between SQS and SNS. Let's move to the management console and let's have some hands-on practice for the SNS. So we'll write simple notifications. I'll write simple SN. That's a simple notification service. Click on this. Very easy. And you'll get the home default window. You know already. You need to create the SNS topic. Let's try to create. Start, and the interface looks familiar as we have seen already. So this is cannot be modified after creation, first in first out, or you can have the standard one. So there's a few features that are mentioned: best effort message ordering, at least once delivery, highest throughput, subscription procedure by SQS, Lambda, HTTP, SMS, and strictly preserved message ordering, exactly once message delivery, high throughput up to 30 publisher per second. Subscription model is SQS. So these are the few of the options. Let's keep it the standard one. Name we have already given. Okay. Then the next one is encryption model, which is an optional one. And then we have the access policy. You will see access policy we have seen in the last one as well. So similar access policies there. We have a JSON document. So we can set up the S3 buckets, and then SNS topic and send the data to the SQS and so on. Okay. So only the topic owner, everyone who can get this basic and advanced. So all those things are as it is. Let's create and create. So as we can see right now, we have the 0 subscriptions. Okay, so we have the 0 subscriptions, and we need to create our first subscription. So let's click on this. So I'm going to create our one, and so let's have this. A lot of services are there. You can create an email. Let's try to check the email one. Okay, so we need to specify the endpoints. So we need to have an email address that can receive the notification from the Amazon SNS. Let me check if I can create a temporary mail account. Mm, Mailinator. So this is a public email. Okay, this is a, you try Sahil Sharma. Okay, so we can get this. This is working. Let's try to write the temporary email here. So I have got Sahil Sharma, the teacher at the rate of millinator.com. Okay, so this is done. SAHILSHARMATEACHER. Okay, so this is the public inbox. Temporary mail I have got. Okay. So we can get a temporary inbox here, and let's move on here. And then we have the subscription filter policy. Let's click on this, and the JSON policy. This policy filter the message for the subscribers receives. Okay. So this is really helpful for the subscription. If you have many subscribers, it just needs to get only the subset of the message, so you can use this or set your SQ into your SNS topic. Okay. Then we have the subscription filter policy, but we'll not set up this right now. Then we have the retry policy. Let's click on create subscription. So we have, so now we need to validate the subscription. Okay. Let's click on my first topic, and we can see right now it's pending confirmation. Okay. So let's go to the mailinator. Let's confirm it. I'm going to the mailinator. We'll see into my mailinator. I have received an email, and in that email, if I'll open this in my mailinator, I have received. Okay. And by clicking onto the confirm subscription, you can click on this confirm subscription, and you can see the subscription is confirmed. Okay. So we go here now. Let's come back and let's go here. Subscription. Okay. So we'll go to the subscription. Now you will observe it is confirmed. It is confirmed. Okay. Now click on this one. You will see I can look at it. So endpoint is mentioned. So it is Sahil Sharma, the teacher, at the rate of mailinator.com. Okay. So as of now, no filter policy is applicable. So subscription filter policy is empty. So you can add a subscription filter policy here, and all this information is present. Now you can go to the my first. So let's do a test. So I'm going to click on publish a message. So we're going to publish a message. Okay. Message body. Okay. Enter. Let's write hello world. and then we have the message attributes. Let's publish a message. Okay, so the message has been published into my first topic. Okay, message published in my first topic successfully. And if we need to go to the mailinator, and if we go to the back to inbox, you'll see AWS notification message is there, and when you click on this one, so you'll see the hello world message is there. Okay, saying hello world. So they are easy and they're super cool. And so just we have seen how the SNS is working for us. So the message can be sent. So this is a perfect, and we are good to go. So if we wanted to implement the SQS fan out pattern, so we can create a, let's move here, we can create a subscription, and you can type here SQS and many different queues and the receivers. You can have the endpoint of the subscription of SNS topic. Using this, you can do this, or I can click on this one, and let's click this, and let's delete one. You can't undo this action. Okay, so let's delete finally. Okay. And if I'll go to the topics, so you'll see there's my first topic. Let's click on this, and let's delete this, and I need to type delete me. Delete me. So finally we have seen the SNS also. So this is all for SNS. Okay, so let me remove this. This will be done already. Okay, so better let's take a break for 5 minutes, and then we'll come back and continue the rest of the topic. Okay, so take a 5 minute break. Okay, so better let's continue. Let me share the screen. Give me a second. So we are going to start with canines. So it makes it easier to click the process. Basically, but this particular uh, the structure or the organization is used for the data which is the current data, okay, or the live stream data. It is going to capture and it is going to perform the operations onto it. Okay, it makes it easier to collect, process, and analyze the streaming data, that is current data, in the real time. Okay, so streaming data can be processed in the real time. So like the real-time data such as the application logs are generated, multiple matrices, website click streams, if how many users are currently clicking on anything, or IoT telemetry data. So these are the few data that can be Kinesis can process it. Okay, so the four basically models that are going to be used for this processing of the real-time data. So we moreover these all four of them are falling not under the free tier. So these are the paid one. Okay, so we'll be discussing about it. I'll show you a little bit, but we're not going to execute it completely. Okay, so we have the Kinesis data stream, so which is going to capture, process, and store the data stream. So then we have the Kinesis data firehouse. It is going to collect the data and it is going to make a batch file, and then it is going to load the file into AWS S3 bucket or any such thing. Okay, so batch loading is going to be done for the real-time data. The third one is data analytics, analyze the data stream with the SQL or the Apache Flink. And the fourth one is video streams, captures and processes the stores video streams. So these are the four different type of subsystems that are falling under the Kinesis overview. Okay, so let's try to discuss. This is the first one, that is a data stream. So beta, this is the data stream and Kinesis data stream. It is going to be associated with the multiple applications like EC2 instances, client can be there, mobile application system, SDK can be there, or any other agent can be there. So this is the front end that is going to send the data. So it can process sequentially one stream at a time, and maximum up to 1 MB it can process. 1 MB per second it can process, or 1,000 messages per second per shred it can be processed. So multiple bodies can be there, multiple streams can be there that is going to receive the message, and it is going to store it either in the APK, Lambda, Kinesis data firehouse, or Kinesis data analytics. Okay, so this is one of the way can scale number of shreds. So there are only up to n shreds that are mentioned here, so you can scale up. The second one is going to be the data streams, retention between 1 to 365 days. So data streams, they can be stored for single day to maximum 365 days, and ability to reprocess or replay the data availability is there. Once the data is inserted into Kinesis, it cannot be deleted immaturably. Okay, data can be that can shares the same partition, goes to the same shed. So जो भी बेटा आपका similar kind of data होगा, it will go to the same shed or the same ordering. Producers can be AWS SDK, Kinesis producer library, which is called as the KPL, or Kinesis agent can be there. And who can be the consumer? And it can be the AWS SDK can be there, Lambda functions can be there, data firehouse, data analytics. These can be producers and the consumers for the data streams. Coming on to the data streams capacity models. So we have the provisions one and the on demand. Leave this is not required. Then we have the data firehouse, but I was telling you this one. So again, like the data, the previous one will have the multiple uh, clients here. So it can be EC2 instances or SDK or agents, and the data streams can be one of the client, or CloudWatch can be there, AWS IoT can be there. So record is going to be sent to the Kinesis firehouse with a 1 Mbps speed. Now, suppose you don't want to send the data directly, you can have that for the data transformation, you can have the lambda function. So before sending the data to the batch writes, you're going to process the data or to transform the data. So but a batch writes means it will keep on gathering the data, and once it has gathered the sufficient amount of data, so batch writing is going to happen in the data firehouse. And these are three very important components where the data is going to be written: S3 bucket, Amazon Redshift, or Amazon Elastic Search. So these are the 3 points where it is going to be written. And you can have the third party like Datadog, Splunk, New Relic, and MongoDB, and more are coming on the way. But these are the third party partners where you can put the data from the Kenin's firehouse. You can store the data here. The third one is the Apache, or the sorry, HTTP endpoint, that can be the custom destination. So even if it is not the third party, or even if it is not provided by the AWS, you want to store it somewhere else, so you can have the APS for that. And suppose that data failed and it is not being stored anywhere, so you can have the for all the failed data, you can put it into the S3 bucket. So this is how the data will flow in case of the data firehouse. So it is written: data firewalls, fully managed service, no administration is required, automatic scaling can happen, serverless. It is a serverless service, and which is used to the Redshift, S3, and the Elasticsearch. Okay, and you need to pay for the data going through the firewall. So whatever data per Mbps, so 1 MB data that is going inside this data firehouse, for that particular you need to pay it. So these are not the free of course. Near real time, so 60-second latency minimum for the non-full batches, because the batch processing is going to gather the data, then it is going to store. So the latency can be little bit can be there, or minimum 32 MB data at a time you can store it. Okay, support many data formats like conversion, transformation, or the compressions. Supports custom data transformation using the lambda functions. And I have told you, if you want to have some of the operations that can be performed on this data firehouse, you can do it, then you can store it. Okay, and can send the failed data to the S3 bucket. So this is also what we have seen. Okay, so then the difference is given between the Kinesis data stream and Kinesis data firehouse. Streaming services ingest at scale, load streaming data in S3. So write custom code, fully managed. This is real time, near real time, managed scaling, automatic scaling, data storage for 1 to 365 days. No data storage is there. Supports a replay capability, doesn't support the replay capability. So these are the few of the differences between them. Coming on to the third one is the data analytics. Suppose if you want to perform the analytics on the data that is coming in, and what can be the producer for this, the data analytics. So data originating from the data streams or the data originating from the data firehouse can be the sources which can act as an input for the data analytics. Okay, and now Kinesis data analytics can have the two of the basic services, that the fire streams and the firehouse, and it can use for the data analytics. Okay, these are the sinks where the data can end up eventually. So either the applications or load balances or the lambda functions or the Redshift or the S3 buckets. Okay, so basics one, application. Let's move on. Okay, this is too advanced. Let's leave this here only, and let's move to the management console so that I can show you a little bit about the Kinesis data analytics. So I'm going to go on to the management console and simply type Kinesis. You'll get it here. Okay. Now once you have once you are going to reach here, beta, as I have showed you already, create data stream, create a delivery stream, and create an application. So multiple options are there. Benefits are there: data stream, firehouse, and the data analytics. Use cases are given where you need to use all these things. So information is present. Okay, related services, that the services that can be associated with this. And moreover, you can create the data streams, data firehouse, and the data analytics. But this is going to be sets can be uh, this much per hour. Okay, playouts can be this much a unit. So if you don't want to have the cost, but you need not to execute this one because this is not free of cost. Okay, so we can click on the data stream, enter the data stream name. Write anything like test data stream capacity, on demand or provision, total data stream capacity. So it is written maximum 200 MB per second or 2 lakh records per second. So that is the option. Data stream settings can be the capability mode, on demand, editable after creation, data retention period 1 day, and it can be changed. Okay, and server side encryption is disabled as of now. Monitoring is there. So this is how it looks like. You can simply create the data stream, or you can click on the provisioned. If you click on the provisioned, you'll have provision threads. It can be any number of threads. You can increase it. Okay. Average record you can have. Let's have the shred estimator. Data stream specification 1, average record size, and then we have the total size reading from stream. Okay, so this is how it looks like. Let's create a data stream. This is in creation. Okay, so this is active. There can be the producers. Okay, and there can be Amazon Kinesis producer library, that from where the data can be originated. Okay, and then we have the consumers process data into real time, process with the delivery system, view in the GitHub. Okay, then under the monitoring you can see stream matrices there, how much records MB per second is there, get record latency is there, some count, and the age aggregator is there, incoming data. So you can get the data idea from here. Then you'll have the third one is the configuration. Okay, provisioned, write capacity, read capacity, and you can make a changes if you want to have. So this is pretty much everything. Encryption is disabled. You can have enable server side encryption if you want. Keys, manage keys can be there. Add a new tag. So just you can play around, and the moment you play around with it, you'll be able to get a lot of features about it. Okay, so we'll move this and we'll try to delete this, not required. So this is deleting the test. Okay. This is gone. Okay, so better let me take an attendance. So rest topic will start in our next class. Don't leave the session. Let me get an attendance, please. Okay. So I have taken the attendance. But whatever topic we have discussed, try to practice it because the more you practice, the more comfortable you will be. And also try to better complete the assignment that is being allocated to you and upload it into the folder. Okay. So this will be all for our today's session. Better. Thank you for joining the class and we'll see you tomorrow. Thank you. You can leave the session.